more than a quarter of a century, they stood. Sentinels at the gates of the free world. Steadfast as the bedrock on which they were built.
I saw a large plane, like a jet, go immediately headed directly into the World Trade Center. It just flew into it, into the other tower coming from the south.
But in little more than 10 seconds, each of the World Trade Center towers was gone.
Here it comes. Smoke was like chasing you.
September 11th, a day when a nation, shattered by grief, asked why. For one community, architects and engineers who watched in horror and disbelief, there was another question. How? How could the marvel of engineering that was the World Trade Center simply collapse? Somewhere in the twisted steel, in the mountains of debris, in blueprints and drawings stashed away for decades, there was an answer. The search for it began immediately. Experts on how to put a building up would spend months determining how the towers came down. Driven perhaps by a much more desperate question: how can we prevent this from ever happening again? Structural engineer Gene Corley has been investigating building disasters for more than 20 years. But on September 11th, shortly before 9 a.m., he gets the worst call of his professional career. Less than 4 hours later, he is leading an investigation into the collapse of the World Trade Center.
My 94-year-old mother, her comment to me was, "Now, don't you go near those buildings." And I said, "Mother, that's what I do."
Within hours, Corley has building experts on the scene, members of a team quickly assembled by FEMA and the American Society of Civil Engineers. As rescuers dig frantically for survivors, his team searches the rubble for clues, evidence that might tell them how the towers fell and why.
You can see the imprint of the two towers going down into the deep basement.
Structural engineer and team member Bill Baker is one of the first on the scene.
What you saw on television was just a small portion of what it was like there. It was overwhelming. It was not just two buildings. It was a district that was destroyed.
The task is daunting. Looking for needles in a haystack pulverized by the sheer force of the collapse. Two 110-story buildings reduced to a pile of debris only a few stories high. Across the Hudson River from where the World Trade Center once stood, a metal scrapyard in New Jersey has become the temporary home of the twisted steel removed from Ground Zero. It is here that Corley and his team join other investigators, such as Professor Hassan Ostaneh of Berkeley, to get a closer look at the damage.
We need to understand what took place from the time that plane nose hit the facade of the building until the time that everything was on the ground and collapsed.
There is one small blessing. Many scraps of steel are marked with an identification number, stamped 30 years ago when the towers were built.
That mark would tell us exactly where it was in the building. So it was very easy in this case to determine where things were.
After several months of picking through the jumbled mass of columns and beams, the scrapyard has no more secrets to tell. Some steel is moved to laboratories for a closer analysis. The rest overseas for recycling.
So you can see as it comes down, that this top part.
Corley's team turns to other clues, picked not from the rubble, but from hundreds of videotapes and photographs taken on that day in September. Still other clues pulled from the memories of those who know firsthand how the terrible events of that day unfolded.
Tuesday morning was like any other morning. I got to the Trade Center around 8:15, got my coffee, went up to 93.
And I heard this huge explosion, and then it was like a ticker tape parade, confetti just flying down.
I felt the building shake, and the lights rattled and went on and off. And the first thing, we just looked at each other, and said, that's not good.
I said to myself, it's an accident. It happened in Building 1. We're probably okay. And then the plane hit.
Oh my God.
We walked as quickly as we could down the stairs, and I remember just counting the floors and knowing that each floor I was closer to living.
And then when we got outside the building, it was the first time I had any sense of run, run, run.
And then we turned and we saw 2 collapse. We just stood there and watched this building just disintegrate before our eyes. And we ran and we're alive. Thank God we're alive.
Long before the official report is written, Corley and his team are sure of one thing. Thousands lived to tell their stories because of the extraordinary design of the towers, which held them together when it counted most. The South Tower, nearly an hour before collapsing.
Oh my God!
The North Tower, an hour and 42 minutes. Corley is not surprised that the towers survived the initial collision. They were miracles of modern engineering, built to withstand high winds pushing against them with a force even greater than the planes that slammed into their sides. When a bomb exploded in the tower's underground parking garage in 1993, the towers simply absorbed it. Yet the explosion was the same magnitude as the bomb that brought down half of the Murrah Federal Building in Oklahoma City 2 years later. But the explosion of a 767, fully loaded with fuel, was 400 times more powerful than that.
The amount of damage the aircraft did on impact was extremely large. That alone, though, would not have brought the buildings down. We think they would have stood up indefinitely unless there was some other very major event.
That major event was fire. Upon impact, 10,000 gallons of jet fuel shot through the building, pouring down elevator shafts and stairwells. Entire floors ignited in a raging 1,600-degree fire in mere seconds. Immediately, investigators suspect that, as strong as the towers were on the outside, they may have been vulnerable on the inside. Many in the fire community are sure of it.
We know that fire resistance is directly related to the mass of the structure. Now, if you looked at the World Trade Center, that was the ultimate lightweight constructed building.
Retired Fire Chief Vincent Dunn spent 42 years fighting fires, which can run rampant in the kind of modern high-rises that the World Trade Center came to epitomize.
I've come to the conclusion that an architect or an engineer is not the friend of a fire chief.
But Corley insists the World Trade Center towers performed well in the face of extraordinary and catastrophic events. And in the end, they may never know if fire alone could have brought the towers down. Nonetheless, the issue of fire safety is at the forefront of the investigation, driven by thoughts of people who never had a chance to escape.
All the time that we're working on these things, well, we are aware of the terrible human tragedy and the losses to the people that were left behind, so it does weigh on us. One of the main things in our interest in doing this type of work is to find out what can be done in the future to reduce the casualties.
This is not the first time Gene Corley has searched for a silver lining in clouds of dust and debris. In 1995, his investigation in Oklahoma City concluded that damage to the Murrah building could have been reduced as much as 95% had it been designed to absorb more energy, like those in earthquake zones. 7 years later, a new building is going up, built on those painful lessons learned. Even the 1993 bombing of the World Trade Center revealed more of the building's weaknesses than its strengths.
It didn't affect the structure of the two towers. What it did show, though, was the vulnerability of the structure of the towers to smoke and loss of electrical power.
For many of the thousands who fled the towers in '93, the evacuation proved more terrifying than the explosion deep in the bowels of the building.
Going down a dark staircase is a lot worse than going down one you could see the steps, believe me.
Police officer David Lim remembers the panic people felt in those pitch-black stairways after the '93 bombing, and the difference that improved lighting and ventilation would make when he found himself moving frightened people down the stairs of the North Tower on September 11th.
There was a great fear and apprehension in their faces. As I'm getting those people directed into the stairway, right, I'm looking out the window, and I see the second plane go into Tower 2.
The structural damage to Tower 2, the South Tower, was far more severe. Although it was hit by the second plane, it collapses first, standing for only half the time the North Tower does. Early on, the team is convinced that the towers did not collapse in the same way, which only makes the investigation more difficult. For the team, the first step towards understanding how both towers came down is to understand how they went up more than 30 years ago. For many who worked in the towers, who called them home, the World Trade Center was almost mythological, both in scale and in the experience of being within its walls. The way the express elevators slowed down as the towers leaned in the wind. The sight of office doors closing by themselves in the sway of the upper floors. The eerie sounds that echoed through the empty spaces.
All you'd have to do is take a break to go to the washroom and hear these noises coming from the shafts of the elevators, as though giants were playing panpipes. It was like something out of Rip Van Winkle.
But the World Trade Center was a paradox. In many ways, it was as practical as any other office building, with cubicles and bland carpeting and small windows. It was easy to forget, in the daily routine of office life, the sheer size of the center. 50,000 people, more than 300 businesses, 10 million square feet.
Even though I believe that the World Trade Center, in a sense, came closest to a mythological structure, it was still an actual structure that real people lived in. So I think there was always this split between the mythic scale of it and the actuality of, oh, where's the pencil sharpener? You know, who took my stapler?
To architects and engineers, the World Trade Center towers were always more than skyscrapers. They were a marvel of engineering. Nothing like them had ever been attempted in the history of modern architecture. Skyscrapers are a uniquely American art form, born of late 19th century prosperity, when wealthy individuals and corporations fought tooth and galvanized nail to build the most ostentatious symbols of their power and status. Driven by revolutions in steel technology and the advent of the elevator, architects headed for the sky. But by the mid-1880s, with buildings topping 10 stories, they hit the proverbial ceiling.
The walls hold up the building. In order to hold it up, they have to be thicker at the bottom. And once it gets over about 10 stories, they have to be so thick at the bottom that there's no room for a person to walk or do anything useful.
The stage was set for another revolution, and it came in the form of Chicago's Home Insurance Building in 1885. It was the first to use steel cage construction, basically giant metal boxes stacked on top of each other. The weight of the building was no longer carried by the exterior walls, but by the hundreds of columns added to the interior. The race for the world's tallest building was on. By 1930, competition was fierce. During construction of the Chrysler Building, the massive stainless steel spire was actually hidden inside the building. On the last day, the 123-foot pinnacle was hoisted to the top in under 2 hours.
But what they didn't realize is that the Empire State Building builders were even cleverer than that, and they also were holding back.
Less than a mile away, the Empire State Building was being built in record time and under closely guarded plans. When its majestic top was raised in 1931, New Yorkers were shocked. Not only was the building 1,252 feet high and 102 stories, the Art Deco masterpiece was constructed in little more than a year. But it was already a dinosaur. New York and the country were spiraling into the Great Depression. The race to the sky was over. For the next 40 years, the Empire State Building would stand alone against the sky. It was the 1950s and 60s before urban planners began to think big again. Lower Manhattan was deteriorating, and a radical plan for its revitalization was championed by David Rockefeller and his brother Nelson, then governor of New York. With Mayor John Lindsay on board, they set out to build a trade center, the likes of which the world had never seen, and on a shocking scale. 2 110-story towers with enough office space to equal 50 city blocks. But first, they had to overcome what architects and civil engineers had known for decades. The Empire State Building had remained the tallest building in the world for so long because no one knew how to build them taller. Steel cage construction had finally hit its own ceiling.
To build very tall, you needed to have a very large base on the structure because the lowest level had to support itself, plus every level above. That trend was continued as we built skyscrapers, taller and taller. The upper floors generally got smaller and smaller.
Loaded with steel, concrete, masonry, and tile, a building like the Empire State was simply too expensive to construct after the Depression ended. But a new breed of builders had arrived on the scene, and skyscraper design was about to be turned on its head.
This was a new animal. Nothing like it before had ever been constructed.
Structural engineer Les Robertson was only 34 years old when his firm was chosen by architect Minoru Yamasaki for the World Trade Center project.
We had the advantage of youth. That is, it was a time to rethink the skyscraper as a form, not just a structure, but almost all aspects of it.
From the beginning, the World Trade Center towers were designed not to cooperate with the Manhattan skyline, but to redefine it, rising like 2 graceful rectangular sculptures above the city. What Yamasaki had in mind was revolutionary. The World Trade Center towers would not taper at the top. Each floor, nearly an acre of wide open space, would be identical from the basement to the penthouse.
From that standpoint, it made the buildings much more potentially profitable. It meant that you didn't have to sacrifice hundreds of thousands of square feet of space to steelwork. The steelwork was all on the outside.
Those steel outer walls were the hallmark of Yamasaki's design. Instead of heavy columns breaking up the interior, the towers were essentially hollow tubes, what Yamasaki likened to bamboo, except these were square, made of metal, and impossibly tall. The core columns, made of more standard steel, carried the bulk of the building's weight. In between, floor trusses spanned the interior to connect the core to the outside columns. This floor system was the key to the tower's exterior strength, because in scale, the perimeter columns were as thin and as flimsy as a sheet of paper.
Which makes them very vulnerable to buckling. We can illustrate buckling with a piece of pasta. Start out with a piece that's about 12 inches long, and with very little pressure on the end, I can get this to buckle. See, it's not breaking, but it is buckling, and it isn't able to carry much in the way of load. If I go with a piece half as long, I can still get it to buckle, but it now takes about 4 times as much load before it buckles. Now, if I take one that's about 1 inch long, I can't put enough force on it with my finger to cause it to buckle.
And that was the effect of the floors. Instead of long pieces of wobbly pasta, in essence the columns became stacks of short and squat columns when braced by the floors, which made them very stiff and very strong against the elements. In high winds, a building that tall could sway as much as 3 feet off center. So, the World Trade Center towers were the first buildings in history to undergo model wind tunnel tests.
You do not dare build a 110-story building on a technology designed for barns, right? You must go a little farther than that. And so a huge amount of work was done measuring turbulence over the city, things that had never been done before.
It was 1965, and before a drop of concrete was poured, an I-beam raised, the Twin Towers had rewritten the book on skyscraper design. Now, all that was left was to build them. Real estate is hard to come by in the Big Apple, where thousands of buildings are crammed into one small island. So, before the World Trade Center could go up, 16 square blocks of turn-of-the-century Lower Manhattan had to come down. The task of clearing the site was monumental. 164 buildings had to be demolished, underground utilities rerouted. One of New York's oldest subway systems, the PATH, kept intact and running. But another hurdle loomed: how to keep the Hudson River out of the foundation of the world's tallest skyscrapers.
It wasn't just a question of going down and finding bedrock on which the skyscraper could rise. It was also a question of creating a concrete basis that would resist the forces of nature from the sea.
The solution was to build a massive concrete bowl at the site, nicknamed the bathtub. The walls of the bathtub, more than 3 feet thick, took an entire year to build around the 16-acre site. Once the walls were completed, excavation inside the bathtub could begin. More than 1 million cubic yards of dirt were removed and dumped into the harbor, creating what is now Battery Park City.
So the World Trade Center itself owned landfill, then creates the landfill for yet another expansion of the city into the Hudson River.
Steel construction began in 1968. The towers required more than 200,000 tons of it. And nearly 500,000 cubic yards of concrete, enough to build a sidewalk from New York to Washington, D.C. Storage space and transportation were at a premium at the site. Once again, engineers would have to reinvent the wheel.
We came up with an entire new construction methodology for the building. Everything was new. We started with the premise that we would prefabricate pieces to an extent that had never been done before.
Perimeter columns were pre-welded in 36-foot sections and hoisted into place by massive kangaroo cranes imported from Australia. The floors were also prefabricated, the 60-foot sections arriving at the site precisely at the moment they were needed. In less than 3 days, an entire acre of floor could be laid.
That floor system is very lightweight. It's made of steel bar joists that are really optimized to be as light as possible, similar to the bar joists that you can see in the ceilings of Home Depots, Kmart's, things of that sort.
Because the floors were so light, the 60-foot sections simply sat on shelves welded to the interior and exterior columns and attached to the shelves with 2 bolts at each end. The floor truss was then welded to the shelves for added strength. Once the sections were in place, a 4-inch layer of concrete was poured over the metal deck, and the workers moved on and up. When the buildings opened in 1972, the accomplishment stunned Manhattan in more ways than one.
I think many people just reacted to it as though it was some sort of Martian implant.
It would take years for many New Yorkers to warm up to the towers which overpowered the skyline.
World Trade Center is kind of like a wall, a sheer wall around it, and you don't want to walk along that wall. It's boring. You have to kind of get inside of it, either through a train. Once you got inside of it, then it's a big shopping mall with giant buildings on top of it. That's kind of un-New York-y.
But over the next 25 years, the World Trade Center and the tens of thousands of people it sheltered would witness much in its short life. Some events endearing it to the city, such as the occasional publicity seeker, a tightrope walker.
This morning, a young Frenchman named Philippe Petit walked a tight wire from tower to tower.
A real-life Spider-Man.
He started at 6:30 this morning, and by 7:30 he was already 30 stories up.
A parachutist.
35-year-old Vietnam veteran John Carter, who jumped on the World Trade Center from a small airplane at an undisclosed altitude.
Other events in the tower's history were much more serious. A raging fire on the 11th floor in 1975. The blackouts of 1977. Even a near miss with an Argentine airliner in 1981. Then, in February 1993, the bombing that shocked a nation, leaving 6 dead, more than 1,000 injured.
The scene remains the same. Still, streams of people, hundreds, thousands actually, by now, have come out of the World Trade Center building.
It was after the bombing that New York finally seemed to embrace the World Trade Center as one of its own. It was wounded, but it was still standing.
We could then see it, if not as a beloved architectural icon, as certainly as a symbol of ourselves and our resistance and our resilience. So it became possible for us to really, as New Yorkers, I'm not talking about how other people saw it, but as New Yorkers, collectively to say, ah, this is New York. It's tough. It's not going to fall down.
No one could anticipate the chain of events of September 11th that would ultimately do just that. Cripple the mythological giant and send it hurtling to the ground. September 11th begins like any other day at the World Trade Center. By 8:30 a.m., thousands are already at their desks or hurrying upstairs with breakfast and the morning paper. At 8:46, their world turns upside down. American Airlines Flight 11, hijacked out of Boston's Logan Airport, slams into Tower 1.
I was standing facing a window, and I heard a motor, and I saw a wing, and it was like not straight out like this, but like tilted. It's like, whoa.
Daphne Carlisle is on the 82nd floor, only 15 stories below the impact. What she sees out the window confirms what Corley's team suspects immediately. The pilot positioned the plane to do as much damage as possible.
Here you see the plane, and it just as it gets into this area, it banks quite a bit and hits the tower at an angle.
From the moment of impact, Gene Corley and his team attempt to recreate the chain of events that caused the towers to cascade to the ground like water.
The main entrance to the plaza was really off Church Street here.
For the team, the initial question is not how the towers came down, but how they managed to stay up after being struck by an aircraft nearly as wide as the building.
When the plane hit, it took out almost 2/3 of the columns on the north side of the building. Despite that, the building was able to redistribute the way it carries the load. The columns actually then started carrying the load around the gaping hole.
Although the damage is severe, the team believes it is not enough to cause a collapse of the entire structure. They turn their attention to the intense fire that follows. Ladder Company 6, from their station half a mile away, sees the massive fireballs erupt from the building. They're on their way before the first call comes over the radio.
I have my head out the window, and I'm watching this thing, and I see debris coming out, and that's what I thought it was, debris.
It wasn't. In the South Tower, attorney Kelly Ryer watched in horror from his 100th floor office.
You could see directly into Trade Center 1 at their eye level, and that's where you saw people just holding on and just leaping. because they had no place else to go. The flames were so severe.
Jet fuel can burn fiercely as high as 2,000 degrees Fahrenheit, but not for long. Corley's team estimates that as much as a third of the fuel explodes outside of the building. What remains inside burns for only 8 minutes.
So we think that the main factor involving the fuel was that it started the fire in several floors all at one time.
Fire is everywhere that the burning fuel has sprayed. Since very little of the fireproofing protecting the steel is found in the rubble, Corley's team believes that the fragile spray-on fiber is knocked off in the incredible violence of the impact, leaving many of the core columns and floor trusses naked to the intense heat of the fire. It is 9 a.m. Daphne Carlisle struggles down 82 flights of stairs. Water is pouring down the steps.
I remember slipping. And I remember my coworker trying to catch me. He slipped.
Eyewitness accounts like Daphne's lead the team to suspect that water supply pipes located in the exit stairs have been severed by the impact. Sprinklers throughout the North Tower aren't working. Ladder 6 knows the fire is bad. They don't know that there is no water to fight the fire with once they get there.
We're probably going to end up having to lose 5 or 6 floors, but we can put this fire out.
In the South Tower, Kelly Ryer has just made it down from his office to the 78th floor sky lobby. Suddenly, everything explodes around him. It is 9:03 a.m. The second plane, also out of Boston, barrels through the south side of the tower at an angle, smashing through floors 78 through 84.
The engine came through the northeast corner of the building and flew out and landed several blocks away.
Although there are many angles of the South Tower, the key piece of video comes from the New York office of engineer Bill Baker, one of the team members, taken from a window by associate Dean Revere. The video shows the severity of the structural damage. The floors in the impact area are decimated. Flames and black smoke indicate a raging fire inside. In the 78th floor sky lobby, nearly everyone is killed instantly. But Kelly Ryer is alive.
I realized that I was in the elevator, which was mangled. It was split open, the sides were split open, the floor was blown up, and there was an inferno in the elevator shaft that you could just see.
Kelly races back to the stairway he has just left. Daphne, in the North Tower, is near the end of the stairs, and her stamina.
I was getting tired. I was wondering if I was going to make it out. I would die there from exhaustion.
What Daphne sees when she finally stumbles outside is ominous. Black smoke is rolling out of the top of the North Tower. Inside the building, the end is nearing. The team determines that the core columns not destroyed by the impact are holding up much more than their share of the weight, and many are losing what strength they have in the heat of the fire. The situation in the South Tower is even more dire. Despite the sharp angle of the plane, it is still able to rip through a massive section of the core. The tower can barely hold itself together. After climbing down 78 flights of stairs, Kelly Ryer runs out of the building. He gets only a few feet before he hears the worst sound of his life.
I just heard this groaning explosion, and turn around and look, and you just see the top of Trade Center 2, just a big, huge ball of fire come out, and the top just sort of start to topple over towards me.
It is 9:59 a.m. From the 25th floor of their architectural firm, Dean Revere and his colleagues watch the South Tower crumble before their eyes. After the initial shock, they realize that they have in their hands the perfect view of the South Tower's collapse. Only days later, Corley's team is able to dissect the video. For nearly 45 minutes, fire burns through the impact floors. Inside, steel columns and floor supports are heating their way towards failure. Suddenly, a puff of smoke shoots out of the east side. There's been some kind of a collapse. The team suspects that a heated and sagging floor is finally breaking free from its connection to the core columns. Without the support of the floor, the perimeter columns buckle out and snap immediately.
All of the columns just let go on that side, and the building started to tilt just a little bit toward the east.
The top of the tower falls over in the direction of the weakest, most damaged corner. Instantly, the floors below the impact collapse and pancake down on top of each other. It takes less than 10 seconds for the south tower to hit the ground. Daphne and Kelly make it to safety, with scores of others who are able to outrun the cloud of debris. But Ladder 6 is still inside Tower 1. From the 27th floor, they are moving as fast as they can back down the stairs. They make it only as far as the 4th.
And that's when the building started shaking, and you heard the rumble. And I said, oh, here we go. This is it for me.
When the collapse finally starts, the antenna started just a little bit before the exterior of the building started. And that tells us that the core columns let go first.
At 10:28 a.m., the weakened core columns of the North Tower finally give out in the intense heat of the fire. They instantly try to shift the weight they're carrying over to the perimeter columns, but it's too much to bear. The outside columns break around the impact floors, and the top of the tower slams down. Puffs of smoke and debris are expelled from the side of the building as one floor falls on another and another. The progressive collapse is over almost as it begins. One jagged piece of the exterior remains standing for a few minutes, and then finally falls over in defeat. But deep in the rubble of the North Tower, there is one other piece of the tower that is standing, a stairwell. Inside, 6 incredulous firemen.
I said, Rich, there's nothing over our heads. We had 106 stories over our heads, and now I'm seeing sunlight.
Their survival in that stairway would be one of the few miracles to happen on September 11th. Now that Corley's team has a clear understanding of how these massive towers came down, it is up to them to put together their recommendations for the future, to find some other good in a day marked by such evil. In its 133-year history, the fire service has lost 770 firefighters in the line of duty. It lost a number equal to nearly half that in a single day.
Take any gear we can carry, especially first aid stuff.
Once we're on the 27th floor, we heard that rumble that nobody's ever heard before, a 110-story building coming down.
Just rained building. I'm just very concerned about the 6 firemen who were with me because I'm not sure they all made it.
I'm telling you right now, there wasn't time to evacuate our people.
They're all heroes, each and every one of them. To face that kind of danger is a tremendous thing to look at when everybody else is running out.
On that day, fire chiefs on the scene knew they were sending firefighters into danger. They did not know that they were sending them to their deaths. Never in the history of modern architecture had a building been known to collapse because of fire.
Well, you have localized floor collapse at almost every serious high-rise fire, but you never have total wall collapse or 2 or 3 or 4 or 5 or 110 stories come down like that.
Retired Fire Chief Vincent Dunn points out that September 11th was not a high-rise fire. It was a catastrophic event caused by 2 flying bombs. But it was a wake-up call, and they have finally brought to light what Dunn calls the fire department's best-kept secret.
If you're a city manager or if you're a fire chief and you want to keep your job, you cannot tell the people that we cannot extinguish a fire in a high-rise building.
Although these buildings are considered fire-resistant, including the World Trade Center, Dunn says they simply don't do enough to stop fire from spreading from one floor to another and raging out of control of firefighters.
We're expecting a 20-floor fire in this decade, sometime, somewhere in America.
Chief Dunn blames the design and construction of modern skyscrapers for many of their shortcomings. In an effort to make structures like the World Trade Center lightweight, engineers eliminate the very things that make older buildings tougher and more fire-resistant: concrete, brick, and tile. In the World Trade Center and in most modern buildings, steel is protected by a thin layer of spray-on fireproofing, which keeps the steel from heating and losing strength in a normal office fire for several hours. But September 11th was not a normal anything.
Supposedly this was fireproofing, but you can see that only a little piece of it is left here.
When steel is laid bare to intense fire, its strength is measured not in hours, but in minutes. That the World Trade Center held together as long as it did has mystified many engineers. Now, many new buildings are actually turning back the clock to a more rigid construction.
In the Petronas Towers that we designed in Kuala Lumpur in Malaysia, the structure is not steel, but it's reinforced concrete, high-strength reinforced concrete.
Cesar Pelli is the architect of the Petronas Towers, currently the world's tallest skyscrapers. Steel is a very expensive import in Malaysia, so the technically advanced concrete was a practical solution. Still, it is much less vulnerable to fire than steel. The Petronas Towers also have stiff concrete cores. Not only do they protect the stairs, elevators, and mechanical equipment, they can stand alone, even if the rest of the building falls down around them.
The vertical elements, because they are concrete, I believe would have held longer and therefore would not have allowed everything to collapse quite as fast as it did in the World Trade Center.
On September 11th, the men of Ladder Company 6 believe they survived the collapse of the North Tower for one reason. They happened to be in the staircase on the 4th floor, which was nothing like the drywall encased stairs found throughout the towers.
This stairway had a masonry wall that attached to this mechanical equipment room, and that's what really saved us.
Being completely safe from attack is another matter. There is really nothing short of a nuclear containment facility that can resist the impact of a 767. And that's the kind of construction it would take to create a truly terrorist-proof building.
It would be claustrophobic kind of space. Not the kind of wonderful space that was the World Trade Center. When you were at the top of the World Trade Center and the sun was going down, I mean, it was glorious. It would not be like that. It would be just a jail. It would be a fortress or whatever you want to call it. It would not be a place that you or I would want to work.
And that is the greatest, perhaps most lasting effect of these terrorist attacks: fear. Fear of working in a high-rise, high-profile building, and fear of building them. What worries many in the architectural community in the aftermath of September 11th is a stifling of creativity, a reluctance to push the envelope and take risks, which is what defines American architecture and what defined two monumental icons that once rose to meet the sky.
I don't think there's any question about rebuilding the World Trade Center, because I think the powers that be, and in that I include the popular will, I think will not be able to tolerate this big gap in our urban fabric. I would hope that something is left so that people passing through would be able to ask what was here.
For nearly 30 years, the World Trade Center stood as a remarkable achievement of human ingenuity, a corporate cathedral of wealth and power, a glimpse of cities yet to come. And even in its final tragic moments, it is a testament to change, a lesson for the future, so that their loss and the loss of the nearly 3,000 lives they once sheltered can be as meaningful as they are mourned.
Coming up, As Discovery remembers those lost on September 11th, take a look back at the attack on the Pentagon through eyewitness accounts of the plane crash and the chaos and mourning that followed.